Good evening, everyone. My name is Nathaniel, and today we're going to dive into an interesting topic in data analysis, symmetry and asymmetry in data distributions. This is a fundamental concept that helps us better understand and interpret the world through data. And I hope by the end of the session, you'll have a deeper appreciation for the role these patterns play in a real world analysis. So later on, I'm going to be showing you formulas, a problem that was that I picked up from my teacher in modern world of mathematics. So I'm going to be showing you that problem and we're going to be solving it using the formulas I'm about to show you. So let's move on to the next slide. Understanding symmetric and symmetric distributions. So key characteristics. Symmetric distribution has a balanced shape, meaning the left and right halves mirror each other. The mean, median, and mode are roughly equal in value, which is a defining feature. Examples include height, weight, and blood pressure measurements. Symmetric distribution is often visualized as a bell curve, also known as a normal distribution. The peak represents the most frequent value, and the data tapers off equally on either side. So on the next slide, I'm going to be showing you a visual representation of a left skewed and a positive skewed, basically right skewed distribution. So let's move on to the left skewed first, the negatively skewed distribution, or the negatively skewed distribution. It tends to have a longer tail, long tail to the left. A left skewed distribution has a longer tail extending towards the left side of the distribution. The mean is pulled to the left by the extreme values on that side. So the median tends to be larger than the mean. Uh, for the left skewed distribution, indicating the data is skewed towards lower values. So it focuses more on lower values. So here's a real world example. Examples include income distribution, where a few high earners pull the mean towards the right, while most people have lower incomes. Uh, in other parts of, let's say, in other parts uh, of countries that are not that high earning. So that's about it for the negative skewed. Now, moving on to the right skewed, positively skewed distribution. Long tail to the right. A right skewed distribution has a longer tail extending towards the right side of the distribution. The mean pulled to the right by the extreme values on that side. So, meaning the tail is longer on the right side of the data. So, the mean tends to be bigger than the median. Uh, Indicating the data is skewed towards higher values naman for this one. So examples include test scores where a few students might score very high, pulling the mean upwards while most students have average scores. So that's an example that we can all relate to. So moving on. Here is the formula that we will be using later on. So you have to remember this formula, the Carl Pearson's coefficient of skewness. So what is this formula all about and how do we use it? So the Pearson's coefficient of skewness is a mathematical tool, um, a statistical measure that quantifies the asymmetry of distribution. It provides a numerical value for the degree of skewness present. So measure of skewness. A value of 0 indicates a perfectly symmetric distribution. Uh, Positive values indicate right skewness, while negative values indicate left skewness. So interpretation naman, the magnitude of the coefficient gives an indication of the severity of the skewness. Larger values corresponds to more pronounced skewness naman. So that's basically just the summarization of the Pearson's coefficient of skewness, and we're going to be using this later to answer a problem table. So here we go. So here's just a text explanation on how to use that formula that we saw earlier. So calculate the mean. Find the average data of values by summing all values, dividing by total number of values. So step 2, calculate the standard deviation. measure the spread of data around the mean by calculating the square root of the variance. And step 3, apply the formula, the formula that was shown previously, this one. We're going to be using it later on to basically find the coefficient of skewness. So moving on, interpreting the Pearson's coefficient of skewness. Positive coefficient indicates a right skewed distribution where the tail extends towards higher values and the mean is greater than the median. Negative coefficient indicates a left skewed distribution where the tail extends towards lower values and the median is greater than the mean. And zero coefficient indicates a perfectly symmetric distribution where the mean, median, and mode are approximately equal. So all we have to remember is for positive coefficient, it's always the right skewed distribution and the mean is greater than the median. And for the negative coefficient naman, left skewed distribution where the tail extends towards lower values. And for zero coefficient, the mean, median, mode are approximately equal. So that's a thing to remember for positive and negative and zero coefficient. So moving on, here's another text problem. Example problem analyzing a dataset using the Pearson's coefficient dataset. Here are our data values: 10, 12, 15, 18, 20, 22, 25, 28, and 30. So all you have to do is get the mean of this, get the mean, median, mode of these values. So let's analyze this dataset. First, calculate the mean, median, mode, and the standard deviation. And after you've done that, we have to apply all of those values that we got and put it here. So formula, basically 3 times mean minus median over standard deviation, and that will basically give us the numerical assessment of the distribution of skewness. So here is problem number 1. So I got this problem from my teacher from his PowerPoint presentation, and I'm going to be explaining to you on how we can apply this formula. So first thing, we have the values 1, 6, 6, 7, 8, 8, 9, 9, 9. So all we have to do is list it down. It's in table form right now. So for the x, our x is 1, 6, 6, 7, 8, 8, 9, 9, 9. So we have to calculate the mean. So how do we calculate the mean for this one? So all you have to do is add all of these numbers and then wait, all you have to do is add all these numbers and so let's try in the calculator. If I'm not mistaken, we have to add all the numbers to get the mean and divide it by the number, the total number of the total population of these numbers. So the summation of these numbers is what I mean. That's how you get the mean. The mean is 7. Now to get x minus mean, so x represents the values. So all you have to do is just subtract the mean with the values of x. So we get 6. 6 minus 7, negative 1. 6 minus 7, negative 1. 7 7 minus 7 is 0. 8 minus 7 is 1. 8 minus 7 is 1. 9 minus 7 is 2. And 9 minus 7 is 2. 9 minus 7 is 2. So that's how we get the x minus mean values. So right here we can see we will be moving on to our next step in the table. So all we have to do is raise to 2 the values that we got from x minus mean. So 6 raised to 2 is 36. Negative 1 raised to 2 is 1. Negative 1 raised to 2 is 1. 0 raised to 2 is 0. 1 raised to 2 is 1. 1 raised to 2 1 raised to 2 is 1, and so on and so forth. So that's how you get the the values that we see here with uh, the last table. So now let's move on. Now that we have all our values, all we have to do now is solve the for the skewness. So how do we do that? So right here we have a representation for skewness. So we have to take the summation of this one, the summation of x minus mean raised to 2. We have to take the summation. So what is the summation of all of this? So the summation of all of this basically is, let's solve for it. Summation of all of this. So 36 plus 1 plus 1 plus 0 plus 1 plus 1 plus 4 plus 4 and plus 4 is equal to 52. So that is the summation of x minus mean raised to 2, 52. So we have to remember that value, 52. So after that, we put 52 right here and minus, so we put 52, 52 over n. So you're probably asking, how do we get n? So we get n by adding all this up, all of this, or the highest value in x. So our n is 9, so that's automatically our n. So n minus 1, summation of x minus mean over 2 is equal to 52 over 9 minus 1. We get 2.5. That's how we get 2.5. So that's basically how you solve for the skewness. That's how we use the Pearson's coefficient skewness to get the data, which is 2.5. It's not shown here, but that's how you basically get it from basing off my explanation. So here's another one. So we're not done yet. After we get the S, we're gonna be moving on to the final formula. So you have to find the mode. So the mode for this problem is 9 because it's the most repeating value. Remember, the most repeating value is equal to the mode. So the most repeating value in the x is 9. So we're just gonna do mean minus 9 over s, which is 2.55. So the answer is 0.78. So that's basically how you solve for the problem. I hope you've learned a lot, and that's about it. That sums out our session for symmetry and asymmetry distributions. Thank you.